Think about the apps you use every day. When you open YouTube, it somehow knows which video will catch your eye. Netflix suggests shows that actually fit your mood, and ChatGPT answers your questions as if it's been studying the topic for years. This happens through machine learning. The computer studies a sea of data to find patterns on its own, bypassing the need for a human to write a specific instruction for every single scenario it might encounter. For a long time, computers were more like calculators. If you type 5 plus 4, it gives you 9 because it was told exactly how to handle those specific numbers. It does its job perfectly, but it never changes, never improves, and never learns from yesterday. But look at these photos. You see different colors and sizes. Some cats are sleeping, others are running, yet you instantly recognize the pointy ears, the whiskers, and the curve of a tail. We are now teaching computers to do the same. By moving away from fixed instructions, machines are beginning to study streams of information to see how the world actually fits together. To understand how this works, think about teaching a puppy to sit. On the first day, the puppy is confused. You say the word, show the action, and offer a treat. After enough practice and repetition, the puppy connects the command to the movement. Computers follow a similar path during their training. They are fed massive amounts of training data, millions of examples of an object, like an apple. The computer looks past different colors and backgrounds, identifying common features like the roundness and stem to build a mathematical understanding. Once the computer finishes its study, we can show it a brand new photo. The computer compares this new image to the patterns it already knows and makes an educated guess. This guess is the prediction. Because it learned the shape of an apple rather than memorizing a few specific pictures, they can now identify an apple it has never seen before with high accuracy. This training usually happens in two ways. The first is supervised learning, which is like working with a teacher. The teacher holds up a flashcard of a fruit, and the correct name is already written on it for the student to see. In this setup, humans provide the training data along with the correct answers, or labels. The computer makes its guess, checks it against the label, and adjusts its logic until it stops making mistakes. But sometimes there is no teacher. In unsupervised learning, the computer is given a messy box of mixed-up, unlabeled toys and told to organize them without any instructions. The computer searches for its own connections. It notices that objects share the same shape or color and automatically clusters them into distinct groups based solely on shared features. This is how your music app works. It notices you listen to several upbeat pop songs and groups similar new tracks into a playlist for you, even though no one told the app exactly what genre you were looking for. Depending on the goal, whether it's identifying a specific disease or recommending a new book, scientists choose the learning method that fits the complexity of the data. It's important to remember that a computer only knows what we show it. It doesn't have a human's intuition or life experience. It only has the data it was fed during training. If we provide the computer with bad information, like thousands of pictures of dogs but labeling them all as cats, the computer will learn the wrong pattern. It will confidently give you the wrong answer because that's what the data taught it to do. Since data is the fuel for this entire process, humans have the job of making sure that information is accurate, clean, and representative of the real world. These patterns are working all around you. Machine learning is what allows your phone to recognize your face in different lighting, and it's what helps navigation apps predict a traffic jam before you even reach the highway. Here, an AI has studied millions of medical scans to learn the subtle patterns of a fracture. On the right, you can see how it highlights specific areas on an X-ray, acting as a second set of eyes to help a doctor catch details the human eye might miss. This technology is tracking the migration of endangered wildlife through autos, and it is allowing self-driving cars to read road signs and detect pedestrians in the middle of a rainstorm. While the computer provides the analysis, the final choice still belongs to us. AI offers a recommendation based on statistics, but humans provide the ethics and judgment to decide how that information is used. We are using these systems to manage the energy of entire cities and to scan the furthest reaches of our galaxy for new planets. When a computer uses data to solve a problem it was never specifically programmed for, you're seeing machine learning in action. You are the ones who will design the next generation of these tools. Now that you've seen how machines learn, we'll look at how they use that knowledge to make choices in our next episode, How AI Makes Decisions.